kinematics enthusiasts, let's make this quick. I'm sorry if you hear my kids in the background. All right, an object P moves in a straight line such that its displacement s meters from a fixed origin after t seconds is defined by s of t equals negative 2t squared plus 12t between 0 and 8, as shown in the following diagram. Okay, object P starts at the origin and passes through the origin again after a seconds. Okay, so we have an object moving in a straight line. We're talking about the displacement function, S of t. This is going to go ahead and be a kinematics problem. What's the point of classifying it as a kinematics problem? Well, we know that in kinematics problems, the position function, or S of t, but if you take the derivative of that guy, he's going to be the velocity function. The derivative of velocity is going to be acceleration. Okay, so just remember S, V, A to remember the relationship. Okay, so the problem says that object P starts at the origin, this is the origin, and passes through the origin again after A seconds. Okay, so what are we talking about here? We're talking about the x-intercepts of the position function, right? Or t-intercepts in this case, I guess. All right, so we've got A. We're trying to find the value of A. We're trying to find the second x-intercept here. So we've got negative 2t squared plus 12t equals 0. Factor it. Now t equals 0 is the origin. We already used him, so we're going to use t equals 6 for A. A equals 6. Now it says object P changes its direction after B seconds. So we know that an object changes its direction when the velocity is equal to 0. So we're going to go ahead and find the velocity function, set it equal to 0, and find out what B is going to be. All right. Visually, we know that the object changes its direction right here at this maximum. That's going to be our B. We just don't know what B is yet. So let's go ahead and find the derivative. So we've got B I. The derivative of the position function is going to be negative 4t plus 12. We're going to set him equal to 0, and we're going to go ahead and solve. All right, so B is equal to 3. All right, so I'm going to start mocking up my little diagram here, okay? I knew that B was 3 and A was 6. Okay, cool. I'm starting to get some info on this guy. So we've got B is equal to 3. Now B double I says find the displacement of object P from the origin after B seconds. So displacement is kind of like, if you think about this as the origin, we're trying to find how many units to the right or to the left of the origin this object is going to be after B, or we just found B to be 3 seconds. Okay, so if S of t is the displacement function, we're going to go ahead and evaluate S of 3 in order to find out what the displacement of object P is going to be when time is 3 seconds. So S of 3 is going to be negative 2 times 3 squared plus 12 times 3. All right, so it's going to be 36, 9, negative 18, 36. So I'm going to get S of 3 is equal to 18. Okay, cool. So that means that when or after 3 seconds, this object is going to be 18 meters to the right of the origin. Okay, so we've got 18 meters to the right of the origin. Okay, so that's going to be our answer for that, guys. And then C. Find the distance between object P and the origin when time is equal to 8. So find the distance between object P and the origin when time is equal to 8. What we're going to want to do here is find S of 8. So we've got negative 2 times 8 squared plus 12 times 8. Okay. I'm doing this guy in the calculator, even though it's probably not a calculator question. My brain is tired from today. All right, I've got negative 32. So let's think about what the question's asking us. It's saying find the distance between object P and the origin, right? So we found that kinematics speak, right? I am currently located 32 units to the left of the origin. They're not asking us in relation to the origin where this thing is located. They're just asking us to find the distance. And whenever you see distance, you should put little absolute value bars because distance is always positive. So all they're asking you here is for the distance from the origin, which is going to be the absolute value of S of 8, which is going to be 32 meters. So then now let D be the total distance traveled by the object P. Okay, so let's think about this guy while he's moving, right? So he started at the origin. This is the origin. Hello. Now, for the first, this is the guy starting at the origin. For the first 3 seconds, right, we found this up here, didn't we? Find the displacement of object P from the origin after 3 seconds. We found that this object was located 18 meters to the right of the origin. Or sorry, let's think about it in terms of time. So that's after 3 seconds, it was located 18 meters to the right of the origin. Then he changed direction. Remember, we found that he changed direction and he returned back to the origin when time was equal to 6 seconds, right? That's what happened when we found the x-intercept over here, right? So that's going to be another 18 meters for him to get back. Then he traveled, where was it? Find the distance between object P and the origin when t equals 8. We found that distance to be 32 meters. So he kept going 32 meters until he got to 8 seconds. Okay? So if you took this guy, you took this guy, you took this guy, and you added it all together, that would be the total distance traveled. So we've got 32 plus 18 plus 18, and that's going to give me the total distance traveled. So we would just do 32 plus 18 plus 18, and you would get 68. 68 meters is the total distance traveled.